Let's think about this example I said at the start of the notes. How many 2's multiply together to give 8? So we know 2 times 2 times 2 gives me 8. So we multiply 3 of the 2's together to get 8. So we call that the logarithm, or the log. The log is 3. How can we write it? Well, if we know that 2 times 2 times 2 gives me 8, 3 lots of those 2's timesing gives me 8, then we can write it in this form with a log. 2, the number down here, we call it the base. So that's the number that multiplies together. The amount of times it multiplies together by itself is over here on the right on the equal sign. And the answer is in here, okay? So it's really important to become familiar with what that represents. Underneath here, it's undoing an exponential or a log. They're the opposite of each other, okay? So the first thing you need to know is how to rewrite something in log form versus exponential form, and how to go in between both. So this first example, let's just practice that. Let's just look at what it's saying, okay? I'm going to call the ones here that have just equal sign, answer being x being what we want to find. So let's look at how this example here became an exponential. So the base was the base of my exponential. The answer over here was the power, and the number that we're logging is the answer. So if I follow that, I like to think of it like this. 10 to the power of this answer is equal to the number in brackets. So that means 10 to the power of x is equal to 100. And then looking at that, 10 to the power of what gives me 100? Well, it just means that x is equal to 2, because 10 to the power of 2 gives me 100. So let's keep following that. 3 to the power of x equals 81. So write that out. 3 to the power of x equals 81. So I'm writing it in exponential form so that I can then look at it and go, oh, yeah, well, I know that 3 to the power of 4 gives me 81. So x equals 4. So now the x is in a different spot. Let's see what happens when I write in exponential form. 2 to the power of this gives me this. 2 to the power of 4 gives me x. Well, 2 to the power of 4, 2 times 2 times 2 times 2, gives me an answer of 16. Let's keep going. X to the power of 2 gives me 9. Write it out. X to the power of 2 gives me 9. What number, when you raise it to the power of 2, gives you 9? Well, x must equal plus or minus 3. Okay, next one. 8 to the power of x gives me 0.15. 8 to the power of x gives me 0.125. Now, on this example here, 0.125, I always check in these questions here. I press your SD button. You'll notice that that's equivalent to 1 over 8. And I know 1 over 8 is the same thing as 8 to the power of negative 1. So therefore, x is equal to negative 1. Last one, 2 to the power of x equals square root 2. Let's write that. 2 to the power of x equals square root 2. I know that square root 2 is equivalent to 2 to the power of a half. So, what does that mean? 2 to the power of x is equal to 2 to the power of a half. Well, x must equal a half. So that's the first skill, being able to write in log form into an exponential form and then solve. Moving on, properties we need to know. If the base and the number we're logging are the same, it'll always equal 1. No matter what number the base is, if we are logging 1, it's always going to equal 0. If we have and you'll find out why this works later, but if we have the base and the number we're logging the same, and it's got a power of x, instead of the whole thing equaling 1, it would equal x. And last one, if we have a base and we're logging with the same base as that number, so I'll do an example because this one might be a bit confusing. Sorry, if it's, let's go 2 to the power of log with a base 2 and then x, think of it as they cancel each other out. The 2 to the power of log 2, leaving us with just x. So just some properties to know for now. Another thing to know then is the different types of logs we can have. So logarithms to the base of e. So log could have a base of any number down here. But one thing we look at in particular is if there's a base e. If something has a base e, the way, and you can think mathematics, we lazy. We always try and find a nice, quicker way to write things. It's more commonly seen as ln x. So whenever you see ln x, know that's the log with a base e. And you'll see if you've got your calculator in front of you, there is a log button, but there's also an ln button. So let's have a look at these. We've got the log of e and e. That's looking at this first property here, gives me a power of 1. We've got here, I'm going to write it out in longer form, log e squared. That's looking at that third property there. We've got a power, think of it all cancelling, and it just gives us an answer of 2. All right. Log e of 10. On this one, I want you to do me a favour. I know that log e is the same thing as ln. On your calculator, press ln 10 for me. So there are going to be certain times where we can put the number straight in the calculator. It wants us to evaluate. Well, I know that, okay, that number I could just put in my calculator. I have an ln button. I have a log button, okay? So if I put in ln 10, then it's going to give me my answer of, well, we'll do 1dp 2.3. Now I could do the same thing, ln 1.4 in my calculator. Gives me an answer of 0.34 to 2 decimal places if I did. Now, one thing I want you to know is you've got 2 buttons on your calculator. So you'll see there is a log button and there is an ln button. What are they? So the ln button we've discovered, that is really log base e. So if you have a question and it's asks you to calculate log e of something, you can just press the ln button and then the number. The log button though, it lets us do log with a base 10. So if there's a question and it's log base 10 and then something, then we just press the log button. So it's important that you know that that's only for base 10. If the base was another number and it asks us to evaluate it, we're going to have to do something else, which I'll show you soon, because they're the only 2 buttons we have on our calculator. So, okay, questions here. Write in index form. Well, a to the power of c equals b. We know how to do that now. Remember, if we've got y equals over here, it's the same as equals y over here. So we've got 10 to the power of y equals 5. It only says to write in index form. It doesn't say to solve it. So I'm not going to go any further than that. E to the power of 2 equals x. And remember, this is the same thing as log ex equals 1. So e to the power of 1 equals x. Okay, now we're going to go backwards. Write it back the other way in log form. So we have log, whatever the base of the index is, the base of the log, 3. And then we'd have to the power of x is equal to y. Log 5 to the power of 3 is equal to t. Oh, sorry. To the power of t is equal to 3, that way. And then we have here, okay, well, that's log e to the power of x is equal to 2. So make sure you're familiar. I could also write that as just log 2 equals x. That's a really important skill. So when you're ready, have a go at the exercise here, practicing that. But I am going to move on. The next lesson is then looking at some more log laws. Now we looked at some properties up here. So a similar idea. These ones are really important. Basically what it's saying is if you are logging something and there's 2 numbers in here that times together, it's the same as if you took the log of each one of those individually and plus them. If you're logging something and there's 2 numbers inside that are dividing, you'll get the same answer as if you log each one individually and subtract it. So that's what this little summary over here is just saying. When two numbers are timesing, it's the same as plussing the logs individually. If they're dividing, it's the same as minusing the logs individually. Kind of like index laws. The last one, I think this is the most commonly used one. If you are logging something and there's a power up here, that is the exact same thing as bringing the power out the front and timesing the whole log by it, which you can see in this second one here. So that's all this says, saying, I always do this little arrow to show that means a power, then it's the same thing as just multiplying. Okay. Some other tips, we already looked at this one on the other page and this one as well. And something, you don't have to memorize this, it just makes sense that I know that 1 over x is the same thing as x to the minus 1. So that's the exact same thing as log of a, x to the minus 1. And what do you know? If I follow that third rule, I got a power. It's the same thing timesing it out the front, which then gives me -1 timesing by log a of x, which is what this is saying. So, next thing, all right, this is the last little bit of information, so I don't want to overwhelm you too much. Let's say I said to you, calculate to so many decimal places log 3. So you'd press on your calculator, the ln button, then 3, and then equals. If I said calculate log e of 2, that's the same thing as ln button 2, okay? All good. If I said calculate log base 10 of 5, same thing. Remember, the log button on your calculator, it has a base 10, so then you just press that with a 5, press equals. But anything else other than a log with a base e or base 10, I can't work that out on my calculator. For instance, if I said, okay, calculate log 3 of 2. If I said to you to calculate that, there's no button on the calculator that has a base 3. So what we do is we use this formula to do what we call change of base. We change it so that it has a base that we can use. And what base is that? We actually most commonly change it so it's got, base E. So what does the formula say? Well, it just says if it's in the form given here, all right, we can rewrite it in this change of base. I'm going to apply, I think it's easier if I just apply it to this question. The way I like to think of it when we're changing it to a base E is it's just ln of the number we're logging over ln of the base number. So I always just think it's another way to write the formula, ln big over ln base. It's an easier way to think of the formula. That will give us the same answer as log 3 of 2. And good news, we have an ln button on the calculator. So as an example down here, if I had to calculate log 2 of 7, ln, the big number, over ln, the base. Put that in a calculator, let's see what I get. ln 7 over ln 2. And I get 2 point, what do we need? How many decimal places? Doesn't say, so let's just go 2 decimal places. 2.8, let's go 1 dp. There's my answer. What does that mean? Well, let's think about this in index form. Log 27 equals x, let's call it. That means that 2 to the power of x equals 7. 2 to the power of x equals 7. So what I've just worked out is that 2 to the power of 2.8 will give me 7. Check it in your calculator. If you do 2 to the power of approximately, remember we rounded, 2.8, it gives us 6.96, and that's because we rounded close enough to 7. So that's what we've just working out. Okay, let's jump in and do some examples, and then you can have a go at the second exercise. Let's go. We've got some log laws here. If we are plussing, remember it's the same thing as timesing. So I could rewrite that as log A, 4 times x, which is just 4x. Minusing, same as dividing. So I could rewrite that as log A, 7 over y. Remember that that's the same thing, the next one, as I'm just going to make my pen a bit smaller. Log 3, remember that's the same thing as n to the power of negative 1. And when I've got a power, I can bring that out the front. So then that's the same thing as negative 1 out the front, which is negative, log 3n. If I have the two numbers here the same, can all just cancel. And the answer's 2. Okay, now I'm going to actually get some answers here. I've got numbers, all right? Let's think, okay, I got minus here. I've got the same basis, so I could use my minus is the same as dividing formula. One thing though is I don't want is one of the logs to have a number at the front, but I know that's the same thing as bringing that up the top. So I'll rewrite that question now. That's the same thing as log 216 minus log 2 to the power of 2, which I know is 4. Now I've got them both just in a log form without any numbers around it. I use my log law. Okay, well that's the same thing as dividing. So log 2 of 16 over 4, and 16 divided by 4 is 4. So it's equivalent to that question. Log 2 of 16 minus 2 log 2 of 2 is equivalent to log 2 of 4. Okay, last one for this part. I've got them both already in a nice log form. Minus means divide. And does that divide nicely? Yes, it does. Gives me log 2 of 4 as well. Now you'll get better with these as we go, okay? You can pause the video and give the rest a go if you like. Otherwise, this next question is quite a commonly asked way. It says, okay, if log 10 of 2 is x and log 10 of 3 is y, express the following in terms of x and y. It's always going to be manipulation of this number to get with the 2 and the 3. I know that log 10 of 6 could be written as log 10 of 2 times 3. That gives me 6. Now I work backwards. Timesing, well, the log law says I would plus. It tells me that log 10 of 2 is equal to x, log 10 of 3 is equal to y. I've just worked it out that it's the same thing as log 10 of 2 plus log 10 of 3. So that just means it's the same thing as x plus y. Okay, how can we manipulate this? Well, it's really 6... 6, I was going to say 6 to the power of negative 1, but it's not. It's 6 over 10. Oh, yeah, okay. So this is really 6 over 10, which is, oh no, it won't. 3 over 5. What am I? There's something little here. I've just forgotten what it is. Let me see. Let's try this. That is the same thing as 6 timesing by 1 over 10, which is the same thing as 6 times by 10 to the power of negative 1. So that would be then the same thing as log of 10 bracket 6. Timesing means we plus, oh yeah, this is working out, log of 10 to the minus 1. When we have a log that is the same, we're logging the base in the same number, it's just going to become the minus 1. It's one of our properties. So then log 10 of 6, I know is equivalent to, I just worked out from the previous question, log 10 of 6 is x plus y. So now I could say that's really x plus y. So that's that part there. Minus 1, so x plus y minus 1. Tough one. Okay, 15. How can we somehow get and manipulate 15? What about, that's the same as log of 5 times 3. Don't know what log 5 is equivalent to. Is there any other way we can get 15? 3 to the power of 2 is 9. Ooh, I could do 3 to the power of 2 is 9. Times that by 3. No. Times that by 2 gives me 18. Minus 3 gives me 15. Tough question. Okay, so what that's saying is that log 10 of 15 is equivalent to log 3 squared times 2 minus 3. I don't think this is going to work out very nicely for us. No. Okay, well, I'll have another think about this and before I put the solutions in on OneNote. So you might be looking at something better here. Otherwise, the only thing I can think of for now is that we would do log 10 of 5 plus log 10 of 3, because when we times, we plus. And log 10 of 3 is equal to y, so it's just going to be log 10 of 5 plus y. I feel like there's more to that, but I'll come back to it. Okay, otherwise, give the rest of these a go for me. We're looking now at solving, so you want to think about, okay, let me look at this one with you. We've got log 4 of 16. Well, I know that when I am timesing two numbers, I can rewrite them as plus. So that must have been log 2. I need to think of what number here would times to give me 16. So it must have been log 2 of 8. So therefore, x equals 8. I'll do the next one as well. 2 out the front is the same as 2 up here. So then log 3 of x is equal to log 3 of 9 squared. So therefore, x is equal to 9 squared, which is 81. What have we got here? Log 10. Let's go let log 10 of minus is the same as dividing. So let me write it as a division. Log 10 of x over x minus 1. Yep, equals 1. The only thing that, think back to our properties way back up here, what gives us an answer of 1 if the base and the number that we're logging are the exact same. So come back to the question now. That means that the base 10 must be the same as that, which means 10 must be equal to x over x minus 1. Let's solve it. 10x minus 10 equals x. 9x equals 10. X equals 9 on 10. Tough one. All right. Evaluate the following on your calculator by first changing the base. Remember, this is where we just go log of the big number over log of the base. Put in your calculator. Log of the big number over log of the base. Put in your calculator. All right. Second exercise there, ready whenever you are. Give it a go for me. I'll also mention that I will make a video coming up of, let me see, just the next lesson. We'll come back to log scales after the exam. They won't be in it. And also exponential equations I'll put in the video as well. So the next video will have everything else you need to know out of this booklet for your exam. Log scales aren't in it, so we'll just come back to that after the exam. So keep an eye out for me posting information about the next video. Watch it over the weekend. That way we can just be focusing on revision after this. I'll also mention that on our OneNote page, I'm going to add in advanced task 3 little tab. And in that, I'm just going to be putting a whole bunch of SFX past papers, some summaries, chapter reviews, and things like that. Okay, if there's anything you want in there in particular, let me know. But otherwise, I'll see you next week.